Okay, here's the next ones, and I really like them. They're permutations with restrictions and repetitions and together. So first of all, we've got the word success. Now, if there are no restrictions on how we arrange this, this is kind of neat. First of all, count up how many letters. 1, 2, 3, 4, 5, 6, 7. So, of course, no restrictions, 7 factorial. But here's the thing. There's 3 S's in there. And if I arrange those, if I swap the S's around, you wouldn't have been able to tell whether that was a different word or not. In fact, it wouldn't be a different word if I just swapped the S's around. And same with the C's. If I swap the C's around in any of the arrangements, you wouldn't be able to tell that it was a different word. And so what we have to do is account for that. And the way that we do that is we count up how many of these things there are. So there are 3 S's. I need to divide by 3 factorial because there's 6 ways to arrange those S's, and I need to remove that. And then I'm also going to divide, I'll keep the color coding going here, by 2 factorial. The 2 factorial is the 2 different ways that the C's can be arranged every time that they are in a word. Okay? And that's the total number of ways. That's not considered to be a restriction. That's just considered different ways. Okay? Now the first 2 letters have to be an S. So what I'm going to do is I'm going to model that we solve the problem first and then we divide by repeats after. So I need to have the first letter be an S, so that has to be an S, and this has to be an S. So there's 3 S's and then 2 S's and then 5 other letters, 5, 4, 3, 2, 1. Okay, and so that's how to arrange it. 3, I'll call it 3 factorial, makes it neat and tidy, and 5 factorial. And then here we go, kicking in with 3 factorial for all the S's and 2 factorial for all the C's. And that is our answer. Now, the S's have to be together. So here's what I'm going to do. I'm going to do like we did before. I'm going to put that package of S's all together like this. Okay? And then that leaves us 4 other places. So 4, 3, 2, 1. And then I can put that package of S's anywhere into those things. There's 5 places. So I'm going to multiply that by 5. Okay? Now that package, well, so that's going to be 5 times 4 factorial, and then I need to divide by 3 factorial for the different 3 S's that can't be straightened out there, and then also for the C's. And that's my answer. Okay, so we're going to do that again with poppies. There's some similar things here, and then we're going to add some more restrictions. How many arrangements of the word poppies, which has 7 letters again? 7 letters. I like to take a moment and just write that out. There's 3 P's. And that's really it for repeats. So without restrictions would be 7 factorial for all the ways to arrange the letters, and then we need to divide by 3 factorial because of that. Now, if each arrangement needs to begin with a P, then we've got 3 ways to put a P, and then after that, 6, 5, 4, 3, 2, 1. 6, 5, 4, 3, 2, 1. 6, 5, 4, 3, 2, 1. Okay, so we've got 3 times 6 factorial, and then divide by 3 factorial to account for the 3 different P's being all different kinds of things. If the first 2 letters are P, okay, so we've got a P and a P, that's 3, 2, and then after that, 5, 4, 3, 2, 1. So we've got 3 factorial, 5 factorial, and then we need to divide by 3 factorial because of all of the P's. Now, if all of the P's are to be together, we're going to imagine this as putting all the P's over here in a package. And then that leaves 4, 1, 2, 3, 4. 4, 3, 2, 1. And then there's going to be 5 different places that I can put that package of p's. So times 5. So I've got 5 times 4 factorial. And then I need to divide that by 3 factorial because those 3 p's, they could be in any different way. And we can't distinguish between them. Okay. Now, next one. First letter is a P, and the next one is not. So we have the first letter is a P. There's 3 ways. And then the next one's not a P. So not P, it's got to be, not P means that there's 4 different choices there. And then after that, nothing really matters. We've used 2 letters, so 5, 4, 3, 2, and 1 for the remaining 7. And so we've got 3 times 4 times 5 factorial. And then don't forget to divide by 3 factorial as our answer. It needs to take account the number of p's.